guys, so before we begin our lesson in our math book, go ahead and take out your Thursday packet, open to the anchor chart that says metric volume, and tear it out. Make sure you tear it out because this is for you, not to come back to me. Okay, so let's look at that and we'll go over it. So metric volume is the same as metric capacity. So this lesson is going to mostly say metric capacity, but it's the same thing as the metric volume. How much liquid does a container hold? Just like with customary capacity, we're measuring how much liquid a container can hold. So for metric volume, we're only going to be talking about two units, milliliters or a lowercase m capital L. Make sure that if you are using the abbreviation for milliliters that you have a lowercase m and a capital L. And that is the smallest unit of metric volume or capacity that we'll be talking about today. It's about the amount of one drop from an eyedropper. So it's very small. So if you take an eyedropper, it's not all that fits in there. It's just the one drop. Or maybe a very small eyedropper, the whole thing. But for most eyedroppers, 1 milliliter is the amount of one drop. And then we have a liter, which is abbreviated as a capital L. Watch out, lowercase l means something different. It means length, I think. And it's about one water bottle. So not like a tiny water bottle, but like one that's maybe about like that tall and like that big around. That would be 1 liter. So the closest customary measurement would be maybe to between a quart and a gallon, but it's not the same as a quart or a gallon. And the closest customary unit to a milliliter would be about a fluid ounce, but a fluid ounce is a little bit bigger than 1 milliliter. 1 milliliter is very small, it's just that little drop. So keep that in mind when you're trying to pick the best estimates. A milliliter is very, very tiny, and a liter is much, much bigger than a milliliter. Okay, so now that we've talked about that, let's move on to the lesson on page 781. Okay, so let's start out by reading the sentences under the title. It says, the amount of liquid a container can hold is its capacity. So remember, anytime we're measuring capacity, we are measuring the liquid in a container. So we're thinking of how much liquid, not anything else, that a container can hold. The liter, abbreviated with a capital L, and milliliter, abbreviated with a lowercase m and a capital L, are units of measurement for capacity in the metric system. So here again we have a liter, and it's a larger water bottle, and then a milliliter, or about the amount of one drop in an eyedropper. Maybe a very small eyedropper would have a whole milliliter, but a regular size eyedropper, it would be about 1 drop. So that is about 1 milliliter. So again, remember, milliliters are very, very tiny, and liters are bigger. They're not massive, but they are a lot bigger than milliliters. It's not like the difference between an ounce and a ton, but they are very different. Okay, so let's go ahead and look at example 1. Okay, so finger a pencil on example 1 and read in your head while I read out loud. Decide whether 300 milliliters or 300 liters is the more reasonable estimate for the capacity of the mug. So we're going to use logic to estimate the capacity. Whenever you're estimating measurement, you're mostly using logic. You are going to look, okay, so 300 milliliters is about the same as 300 eyedroppers or 300 drops from an eyedropper. That's pretty reasonable because 300 bottles is way too much to fit in just a regular old coffee mug. Even one of those big ones that's like this big around, that is still super unreasonable to say that 300 bottles can fit into that cup of coffee. So that means that 300 milliliters, which remember is abbreviated with a lowercase m and capital L, is the more reasonable estimate. So this lesson, the reasonableness is not going to be quite as hard as other ones because the difference in the amount of a milliliter and a liter is so different. But the thing you're going to have to pay attention to is the number that comes before. Okay, because 300 milliliters and 3 liters might seem more close, but still, it would still be much more reasonable to say that 300 milliliters of liquid would fit in this cup than 3 liters, because that would still be 3 big bottles. And we definitely would not be able to fit probably even 1 liter into a coffee cup. So, even though it's going to be pretty easy to determine whether you need to use milliliters or liters, you do need to pay attention to the number to make sure that you don't choose something unreasonable. Okay, let's move on to example 2. Okay, so finger a pencil on example 2, and then read along with me as I read out loud. Decide whether 600 milliliters or 600 liters is the more reasonable estimate for the capacity of the swimming pool. So we're looking at this swimming pool. We're imagining the real thing. And yes, this is just like a little kid's, a kiddie pool, not a big, massive backyard pool. But we still can use logic. Remember, 600 milliliters is about the same as 600 drops from an eyedropper. That would not even begin to fill this kiddie pool. The pool is a larger object, not a massive one, but a larger one. So it would be much more reasonable to say that 600 liters or 600 bottles about this size would fit into the kiddie pool. So that means that 600 liters, which remember is abbreviated as a capital L, is the more reasonable estimate. 600 drops of water would not even cover the bottom of that pool. Okay, let's move on to the guided practice. We are moving through this pretty quickly, but it's because we only have 2 units to choose from. It might get a little bit harder later on if you have to choose, which it looks like you don't. So yes, let's go ahead and move on to the guided practice. Okay, so you should be looking at the guided practice, and the directions say, circle the more reasonable estimate for each capacity. So we're figuring out what the most reasonable amount of liquid that can fit in that container. So number 1, we have like a water bottle like that you might bring to soccer practice or basketball practice or something like that. Is it more reasonable to say that 1 milliliter or 1 drop of water would fit into it, or 1 liter, 1 larger size bottle would fit into it? It's definitely more reasonable to say that 1 liter would fit into it. 1 milliliter would barely quench an ant's thirst, so it definitely wouldn't be the amount of water you'd want to bring if you're doing something active. Number 2, we have a kitchen sink. Is it more reasonable to say that 38 milliliters or 38 drops of water can fit into this sink, or 38 liters, which is 38 larger bottles? Well, we know that a sink is pretty big because you have to put your dishes in it. This is a 2-sided sink, so it's even bigger. So it's definitely more reasonable to say that 38 liters would fit into the sink. Now, number 3, we have a bottle of, I think that's hand sanitizer. Oh, no, soap. Is it more reasonable to say that 220 milliliters or 220 drops of soap, or 220 liters or 220 larger size bottles of soap would fit into this container? It's definitely more reasonable to say that 220 drops of soap or 220 milliliters would fit into that container. So we've been forgetting to do these talk maths, and they're actually really interesting and they're really cool to think about. So let's look at this one. Describe the unit of capacity you would use to measure the capacity of a bottle of medicine. So if you have a bottle of liquid medicine, like maybe cough syrup or something, would it be more reasonable to measure it in milliliters or liters? I want you to think about that answer. Write your answer under here. So pause the video, think about it, write your answer under here, and then play the video to check your answer. Well, it is much more reasonable to use milliliters to measure a bottle of medicine, because a bottle of medicine is usually only like, even the big bottles are like this, which is not even a full liter. So it would definitely be more reasonable to measure a bottle of medicine in milliliters, because again, even the big ones are like this size, which is nowhere near a liter. And most of them are a little smaller than that. So milliliters would be much more reasonable. Okay, so we are not going to do any of the independent practice together because you're going to keep doing what we've done in the examples and the guided practice. Numbers 4 through 9 are just like the guided practice and example 1 and 2, so you're going to choose the most reasonable answer. Think about it. Does however many drops seem more likely to fill that container, or however many bottles? Make sure that you're looking at how much the whole bottle can fit, not how much liquid is pictured. I don't think there are any ones where you can just see where the liquid ends, but remember you're trying to figure out how much the whole bottle will fill. Then for number 10, you're going to pick 3 containers in your house. I'd say probably look in your refrigerator. That's where most liquid storage is. Name the container in the object column, and then in the estimate column you're going to say whether that container is greater than, less than, or equal to 1 liter. So if you have a gigantic bottle of cooking oil, you might say cooking oil bottle, and then you would say greater than 1 liter. Don't use that example though, because I just used it. So do not use that example. Find 3 objects, probably in your refrigerator, maybe in your pantry, or in your bathroom too, because there's definitely liquids like soaps and shampoos and conditioners and things like that in your bathroom. Look for 3 objects, name them, and then in the estimate column, tell whether you think they are greater than, less than, or equal to 1 liter. Then number 11 and 12, you are choosing whether what they say is reasonable. Don't forget to explain why it is or isn't reasonable. So if it is reasonable, why is it reasonable? If it is not reasonable, why is it not reasonable? Number 13, 14, and 15, you are using both your reasoning skills to find an answer or figure out why an answer is wrong, and then or how to solve a problem, and then you will use some critical thinking as well. Now look at the homework. Numbers 1 through 4 are kind of like the guided practice, except this is where you really have to pay attention to the number, because you're not only choosing between units, which made this a little easier because it was either liters or milliliters, and it was pretty easy to tell right away. In this case, you're also going to have to assign the correct number. So for that spoon, not only do you have to choose between liters and milliliters, but you have to figure out, is it 40 of that thing or 4 of that thing that's more likely? And then numbers 5 through 7 are just matching. Make sure to pay attention. If you match one and then you get to, like if you match number 7 and then you get to if you match number 5 and then you get to number 7 and the answer that's left doesn't make sense, you need to check your previous answers to make sure you chose the best one. Don't just match it with the last one, even if it makes no sense. It means somewhere along the line something got messed up and you have to fix it. Numbers 8 and 9 are again yes or no reasonableness questions. Make sure you explain why it is or is not reasonable. And then number 10, you're finding some more objects. Think of a grocery store. Numbers 11 and 12 are vocabulary. And then number 13, you are again choosing the most reasonable answer, but this time you don't have a picture, so you just have to imagine that object. Okay. So that's it for today's lesson. It was short, I know, but we only had 2 units to talk about. So just make sure that you are thinking, does a really small unit need to be used to measure this, or a larger unit? And then how many of those? So pay attention to that. Don't guess. Think about it. Don't just put an answer down really quick. Think about it first. Okay, if you have any questions about math, go ahead and reach out to me later today between 1 and 5, and I will help you out however I can.